Hello everyone, and welcome back to solving LeetCode challenges. I'm solving these challenges as part of the preparation for future interviews, and let's solve today's. And it is medium, like decent acceptance rate. Not very good, but somewhat good. So we have zero indexed array of positive integers and positive integer limit. In one operation you can choose any two indices and swap as long as they swap within limit. Any number of times. But if we have any number of operations, we can do it as many times as we want. Swap 1 and 2. Swap 3 and 4. Okay. Swap 1 and 2. Okay. Swap 0 and 4. 1, 3, 4. And then swap. I get it. It's not indexes, it's values. So we can swap elements if this element is too big to be swapped. I have like fairly complex solution in my mind. So first of all, we will go through array and will sort it. Right, then we will go through array and we will compare like neighboring elements if they are yes, we don't. We have to find these outliers, elements which can be moved. So we will sort. It will be in log n. Then we will go through each element marking, comparing adjacent elements after the sort. So here we have sorted array. So we will compare 1 and 3. They are within limit of each other. So 1 will be movable. We will mark it as true. For example, we will have another array of Boolean. Then we will compare 3 and 5. They are also 2 apart, so 3 will be movable. We will compare 5 and 8. No, we will compare 1 and 3. We will compare 1, 3 and 5. So 1 and 3 movable, 3 and 5 movable, so 3 will be marked as movable. Then we'll compare 3, 5 and 8. It will be movable because 3 and 5. We will compare 5 and 8. No, we will compare as follows. First and second element movable, both of them movable. Then third and 5. This one already movable, 5 will become movable. 5 and 8. 5 is already movable, 8 will be marked as immovable. 8 and 9 all will be marked as movable. Yes. Yes. So let's, yeah, and then we will have basically mask with the elements we can't move. So we have elements of original. We have original elements. We have sorted version of this. And we have some elements masked in sorted version. we want to mask those elements in the original array, because we have to find out which element we can't move, which element is already in place. We can create a set of elements which is immovable. So we can check the set, and if element is immovable in the first array, we will skip sorted version of this, and we will skip position in sorted. No, we will skip position in original array, and we will compare the next position with sorted version. And also, if this element is in sorted version, we will skip it in sorted version. So we will have like masked, we will compare masked two masked arrays. So is there a way to make sorted copy? Sort, it will sort in place, I think. Arrays, okay. Arrays, there's copy of new length, okay. Fill, sort, void. Okay, let's do like that. Copy will be original, new length. Yes, so int sorted will be equals to arrays copy nums and nums length. So we have sorted and arrays sorted. Now we have to have boolean, not boolean, it will be set integers. Move, okay, new hash set. And for int I equals 1, I is less than nums, not nums, sorted length I plus plus, and if sorted I minus 1 minus sorted I, and all of this is math apps is less or equal to limit. So if it's less than limit, we will do nothing. If it's less than limit, we will remove mm, mm, Boolean ref comparison is false. So if they are equals, ref equals true, and we will do nothing. Else, if ref is okay, we will do nothing. If pref is not okay, we will add move and so we are going first comparison. We are comparing previous element with current element. So in this case it will be 1 and 3. They are within limit, so we're just setting pref to true and we are going to the next element. We're comparing 3 and 5. Again, pref is true. Comparing 5 and 8. It's still... No, it's false. We're going here. So pref is true, so it's false. We are doing nothing. And we're setting pref to false. And we are going to the last comparison. There's pref equals true. Let's go with this example. 1 and 7 is false. Pref is false. so it's true. We are adding 1 and going to the next. 7 and 28. No, 7 and 10 is so, but 7 minus 10 is 3, so we probably can't we can't solve it because they are already in place. But we are not masking them. So here it's true, we are setting pref as true, and we are not adding 7. Then we're going to compare 10 and 19. It's false, pref is true, so we will not add 10 to the array, then we will set it to false, and then we will compare 19 and 28. It will be false, here it will be false, and we will add 19. So, and at the end, if ref is false, we will add to imove sorted length -1 -1. Right. So now we have immovable elements and we have sorted and unsorted elements. So int count int not in place equals zero, and for int I equals 0, 0, I is less than length and I plus 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 plus. If imove contains nums I, we will just continue. Int j equals 0, so it will be pointer for the sorted part. If nums file. Sorted. Remove contains sorted J. J++. So we will go to first movable element in sorted array, and if nums I not equals to sorted J, not in place equal just plus plus. So first if nums is at a movable element, we will move this cursor. If sorted at movable element, we will move second cursor, and then we will compare. If they are not equals, they are not in place, so we will have to increment the counter. So now we have number of elements not in place. Return not in place. It's just for now. I want to check if we are okay in this part of the algorithm. Where it is sorted. Copy off. Okay. Copy off. What else you are unhappy with? Integer without s. And you are unhappy with what? Incomparable. Okay, we will return. We will do sorted. Oh, we have to feel sorted. So we can remove this one, and we can set nums I to sorted J. And we will return nums. Right there. Wrong answer. Okay, how it's wrong? And everything is J++. Okay. We will assign and then increment. Okay, again, wrong answer. Now it's lexicographically smallest. This one is lexicographically smallest. There is groups of elements. We can have more than one immovable element within some group, so they are movable within this group. And if we would have here 7 and 6, we will have to swap this. So we can find, in sorted array, we can find borders between two groups. So here we have one group and the second group. Here we have one group, and also the set is not the right solution, just because we can have duplicates. It's not unique. So we will have groups of elements within which of this group we can sort them. There is a lot of hints. Okay. Too complicated. Let's just commit editorial solution and move on. See you tomorrow. Today is a fail.